I've been using similar solids for the last couple of days. You guys have a deeper understanding about how lengths, areas, and volume of similar solids are related together. Let's use that here in this context. Remember yesterday we did the example on the water in the cone? You had a water you filled up. If I didn't fill a little bit at the top, how much water did I put in there if I left a little bit of space on top of the paper cup? Now I have the water in the balloon. A water balloon has a diameter of 5 inches. So here's the water balloon. The length across the sphere, the length across the water balloon is 5 inches long. Water balloon is in the shape of a sphere. The diameter of that sphere is 5 inches. Now I'm going to change it. I want to put some more water on the inside. I'm going to fill it with enough water so that the volume of the balloon is twice as much. What's going to happen to the diameter? I want to figure out what the diameter of the balloon is after I fill it with more water and make the overall volume twice as much. There's 3 different ratios that we can potentially use to solve this question. There's the scale factor for the ratio of corresponding side lengths. There's the area ratio for linking the surface areas together. And there's the volume ratio. If I want to relate the 2 diameters, beginning, the diameter is 5 inches. After I fill it with more water, how long is the diameter? If I'm going to relate the 2 diameters, which ratio helps me do that? Which one is a ratio of corresponding lengths? Scale factor. I need to know what the scale factor is between these 2 diameters before I can set up a proportion and solve. If I try and use the area ratio, I'm comparing like and unlike together. Apples and oranges together, right? Same thing with volume. I have to have the ratio of lengths before I can compare these 2 diameters. Does that logically make sense? Okay. Problem is, I don't think I have the scale factor given. What do I have given within this question? What am I told? Twice the volume. I double the volume, right? So what's the volume ratio? And I put more water inside of it, so I double the size. What's the volume ratio? Or 2 to 1 then, right? The volume of the filled water balloon is twice as much as the beginning water balloon. This new water balloon has twice the volume of what it did before. Well, let's play around with that ratio. Try and find the scale factor. I need to adjust this given volume ratio of 2 to 1. Find the scale factor that I can then use to relate the 2 diameters together. It's like this has already been cubed. A cubed to B cubed is given by 2 to 1. The scale factor that I need does not have the cubes on it. It's just A to B. As you practice on the warm-up on your handout, how do I drop the 3rd power? What cancels out the 3rd power? Cube root. Take the cube root of 2 and the cube root of 1 to turn the volume ratio back into the scale factor. To turn A cubed and B cubed back into A to B. To relate the 2 lengths, the 2 diameters of the spheres together. Obviously, what's the cube root of 1? Cube root of 2. If I type that into the calculator, I think it's some irrational constant. I'm going to leave it in its exact form, the cube root of 2. If I double the volume next, that means I increase the diameter by a factor of the cube root of 2. That's what we've kind of shown so far. If the volume doubles from 2 to 1, I make the volume twice as big. Every length in that sphere, like its diameter, should get bigger by a factor of the cube root of 2. Does that make sense? Okay. The rest of this is just proportions. Cube root of 2 is to 1. That's 1 is to what? Is it 5 to x or x to 5? Why x to 5, Tristan? Explain why. New balloon to old balloon. New water balloon to old water balloon. Cube root of 2 is bigger than 1. I'm going from bigger to small. So I better do that in the same consistent fashion here on the other side of my proportion. You can get the proportion. I think you're almost home. Because now what do I do to solve from here? Awesome. 1 times x, 5 times cube root of 2. Everyone grab a calculator. Let's make sure we know how to find cube roots on there. Because that's one we don't use quite as much as the square root. So sometimes people get it confused on how to type that into your calculator. If you don't know where it is, let me know. If you know where to find it on your calculator, type it in. Do you get the same value I have on the screen? Try typing in this expression on your calculator. 5 times the third root of 2. That gets 6.3. Please let me know. Yours is a little bit different, Kira. You know how to type that on your calculator? That's 3 times the square root, so that's not quite the cube. So this is the absolute one. Any root you want. First have to tell this root. So what's it a 5 first? I want to do 5. 9. There's 3. What's the third root? This option comes second. That's the third root. That makes sense? You can use third roots, fourth roots, fifth roots with that same key. So pick the number for you. All right, I got about 6.3 inches. In order to double the volume, I'll make the diameter an inch and a third bigger. I'm an inch and a third bigger. All right. Running through that short lesson really quick. Any problems with what's up on the board?